In this video, we're going to have a look at some examples on how to simplify expressions using the second index law. The second index law is a to the power of m divided by a to the power of n is equal to a to the power of m minus n. So when you have the same base, you can then subtract your indices to be able to simplify it. That is how the second index law works. So when we're looking at more complex examples involving the second index law, below our list of 4 steps that I recommend to help work through to simplify the expression. The first is to rewrite the expression, adding in multiplication signs in between the numbers and the variables. The second step is to rearrange and group numbers and like bases in the same order in the numerator and the denominator. The third step is to divide or simplify the numbers together. The fourth and last step is to simplify like bases using the second index law. These 4 steps will help you work through and simplify more complex questions involving the second index law. So let's have a look at a couple of examples. In the first example, I want to simplify 12d to the power of 6 divided by 6d to the power of 4. So using the first step, I want to rewrite that expression, adding in multiplication signs in between my numbers and my variables. So that is going to equal 12 times d to the power of 6 divided by 6 times d to the power of 4. So the second step, to rearrange and group numbers and like bases in the same order, is not required because they're already grouped together. So moving on to the third step, and that is to divide or simplify the numbers together. So my number in the numerator is 12 and in the denominator is 6. So I can go 12 divided by 6, which is going to equal to 2. Now, I can also show that by going 12 divided by 6 is equal to 2, and 1 divided by 6 is equal to 1. So that simplifies down to 2 times d to the power of 6 divided by 1 times d to the power of 4. So the next step is to simplify my like bases. And I've got a d to the power of 6 in my numerator and a d to the power of 4 in my denominator. So using the second index law, I know I can subtract those indices to simplify. So that is going to equal 2 times d to the power of 6 minus 4, and that is still over 1. Because it is over 1 in the denominator, I no longer need to be writing my denominator. So I can cross that out. And then that is going to equal 2d to the power of 2. So 12d to the power of 6 divided by 6d to the power of 4 is going to simplify to 2d to the power of 2. So let's have a look at a second example. In this example is 20a to the power of 9 divided by 12a to the power of 6. And the first step is to rewrite that expression, adding in the multiplication signs in between my number and my variables. So that is going to equal 20 times a to the power of 9 divided by 12 times a to the power of 6. So now I can move on to my second step, which is to rearrange and group the numbers and like bases together, which is not required because they already are grouped together. So my third step is to divide or simplify any numbers. So in my numerator, I've got a 20, and in my denominator, I've got a 12. Now, 20 divided by 12 is not going to get me an integer answer. It's going to be a decimal. So instead of using the decimal, I want to keep it as a fraction, but look to simplify it. To simplify, I want to look for a number that I can divide into 20 and divide into 12. That number is going to be 4. So I go 20 divided by 4, which is going to equal 5. So I cross the 20 out and replace it with a 5. And then I look at my denominator and go 12 divided by 4, which is going to equal to 3. So I cross the 12 out and replace it with 3. So now I've got 5 times a to the power of 9 divided by 3 times a to the power of 6. Now I can't divide or simplify those numbers anymore, so I move on to my last step, which is to simplify any like bases. So remaining in my question, I've got an a to the power of 9 and an a to the power of 6. Now, using the second index law, I know when I'm dividing indices with the same bases, I can subtract the powers. So that is going to equal 5 times a to the power of 9 minus 6, and that is going to be over 3 in my denominator. And that is going to then simplify to 5a to the power of 3 over 3. So 20a to the power of 9 divided by 12a to the power of 6 simplifies down to 5a to the power of 3 over 3.